Hi everyone. So picking up from where we left off, in the last video, we saw that how you can use a smart contract as a factory for smart contracts. And we created a factory where we were creating multiple instances of our cold app using the factory. In this video, we are going to see how you can actually create a factory for your dApp and use that to make money. The idea is going to be that anybody who calls your factory or uses your factory will have to pay some Ethereum to use it. So if you had a dApp, you could monetize on it by letting people create instances of that dApp that they can use. So just to recap, I have this factory contract that is already compiled from the green tick here. I'm going to select it. Let me clear out the old instances. I'll deploy it. And then here I'm going to, let me zoom in a little bit. Yeah. I'm going to create a poll app using a question. What is, let's say, 1 plus 1? And the options are going to be just 2. When I create it by passing 0 to polled app array, because this is the first instance, I get the address. I paste this address here and I select polled app and I click on add address, and that should give me my polled app. If I click on get question, yeah, I get what is 1 plus 1. And if I click on options, the 0th option is going to be 2. Perfect. So let me zoom out again and I'll zoom into the code a little bit. Yeah. So now we can start creating, writing code here that we can use to monetize on this dApp. To begin, the first thing that I'm going to do is introduce a new type of a variable in Solidity called an address. So this address is going to be payable and I'll call it owner. So as the name indicates, address basically means that this owner variable is going to store an address, an Ethereum address. And the reason I made it payable is because this owner, basically this address is going to be allowed to accept Ethereum. How? We'll see in a minute. So we will store the contract creators, address here. So whoever deploys this factory will basically get to be the owner of this factory. I'll quickly also add a constructor. So constructor, just to recap, is basically the function that is called when a contract is deployed. In this, I am going to say that the owner is going to be payable message dot sender. So what does this line do? Message.sender is basically a variable, so to say, which is declared when this contract or any of its functions are called. So when the constructor is called, this message.sender is going to hold the value of whoever is calling this constructor, which means that let me clear out the instances again. When I deploy this contract, when I select polled app factory and deploy it, the owner now is me, which is this address 0x5b3 dot dot dot. So yeah, let's move on. What I'll do is I already have a function to get all instances. I'll also add 2 more functions. So let me just copy paste some code here and then we'll walk through what is happening. So first function that I'm going to write is get balance. Let me just copy the definition. There we go. So get balance is a public function which has only view and it returns a event. So basically when you call this function, it returns the address of this dot balance. This here is the contract. So if somebody is using our factory, we will basically say that you have to pay this contract some money, and that money is going to be reflected in this dot balance. So once again, I'll just clear out the contract. I'll deploy it again. And right now when I call get balance, I will get 0 because there is no ETH provided to this contract. So how do we provide ETH to this contract? To provide ETH to this contract, we are going to use another property of this message object. So message.sender contains the address of the person calling this contract or any of its functions. there is another value which is, just message.value. This contains the ETH sent with the function call. How do we do that? We look at it in a minute. But so since we know that let's say we are going to charge 1 ETH for this contract. So anybody who wants to deploy a Pold app has to pay this contract 1 ETH. To do that, we will add a require statement here, and it will say require message.value, which is the ETH sent to this contract has to be equal to 10 times 10 to the power 18. Now, why am I picking 10 to the power 18? So there is a unit of, so ETH is a very large unit. There are smaller units which are called VE, as you can see here. So VE is another like smaller denomination of Ethereum. So similar to, how, 1 rupee is equal to 100 paise, or $1 is equal to 100 cents. Oops, sorry. Yeah, so 1 ETH is equal to 10 to the power 18 VE. The reason that cents are only 100 for a dollar, but VE are 10 to the power 18 for a ETH is so that we can make Ethereum highly denominable. So basically, when I say that message.value here is equal 10 to the power 18, what I'm saying is that anybody wants to use my contract has to pay me 10 to the power 18 units of VE, which is equal to 1 ETH. Okay, I am seeing that. Okay, let's understand what the warning is. It says message.value can only be used in payable functions. Now, this function is only public. For a function to accept Ethereum, we have to add another property to it called payable. So if I add payable here, oops, what that means is now the EVM, the Ethereum virtual machine, knows that when this function is called, you can actually send some Ethereum along with that function call. And that's really it. Basically, now whenever I call this function, I have to pay this much VE to be able to call it. Let's look at how that works. So I'm again going to deploy my factory. And as you can see, I have a bunch of addresses and each address has some Ethereum attached to it. So now 10 to the power 18. Let's try to call this function before passing anything to it. So I'm just going to do a regular function call. I'll just add a string. What is 1 and 1 together? And I'll add two options. One is 2 and the other is 11. I'm also going to copy and paste it so that I don't have to keep copying it again, writing it again. Let me see. If I call it, it failed. The reason is, let me zoom in a little bit. It says the called function should be payable if you send value, and the value you send should be less than your current balance. Debug the transaction to get more information. But we already know that why this failed, because we have this required statement which is saying that the value is 10 to the power 18. It is a required value. So let's see what 10 to the power 18 is. I'm just going to open the console so that I can do 10 to the power 18 here. And that way I don't have to write 18 zeros. I'll copy it. I'll replace the value with 10 to the power 18 way. And again, I'll call this function. And this time the transaction went through. Also, one thing you will notice is that my wallet address has gone down. Let me demo that again. Once again, I'll zoom in here a little bit. Let me close the console. I'll call this function again. And you'll see that, okay, I did not pass any value. So let me paste that 10 to the power 18 string here. I'll call the function. And as you can see, it went from 98.99 ETH to 97.99 ETH. So I have spent 1 ETH in calling this function. Obviously, you don't have to use 1 ETH. You can make it whatever value you want, however much you want, to charge your customers. The last function that I'm also going to add is, now this contract is holding all the money, right? I need to be able to transfer this money to some other address. So to understand that better, what I'll do is, let's say, let me first add a function that will allow me to withdraw this money. I'm going to add a function here called withdraw. WITHDRAW, my bad. It is going to be a public function, but what I'll do is I'll say that require message.sender is equal owner. So this function can only be called by the owner of this factory. And then what I'll do is owner dot transfer address this dot balance. So let's take some time to understand what is happening in this line here. Address dot this means the contract address. Dot balance means the balance available on this contract. And then what I'm saying is transfer this balance. So transfer this balance to the owner. So I'm calling the transfer function on the owner with the balance available on this contract. I could have done this for any other address, but since it's my factory, I will just say that whoever uses this factory has to send me money. So they will keep sending the money to the contract, and at any point in time, I can withdraw that money from the contract. Let's see that in action again. So what I'll do is I'll pick up another address. So I'll pick up the second address who has 100 ETH, and I will deploy my contract again. And as you know, it costs me some gas fees. Actually, let me go back a little bit. Let's say this person, the one with 97 ETH, is going to deploy it. And now somebody else, so this third person with 100 ETH is actually going to use the contract. So this third person, let's call him Bob. Bob wants to create a poll called what is 1 and 2, and the answer could be 3 or let's say 12. Now when they call this function, again it failed because I did not provide any value. So let's say Bob provides 1 ETH, and when they transact now, this transaction goes through. Now Bob was not the one who deployed this factory. So when Bob tries to withdraw this balance, this transaction fails. Let's see what happens when the person who deployed it, let's call them Alice. So the first one, when Alice tries to withdraw this, okay, before that, let's remember our balance. So it's 97.99. When Alice clicks on withdraw, her balance goes up by 98, which is because Bob had sent 1 ETH to this contract. And that's really it. So basically by using the payable parameter and adding this withdraw function, you have now tokenized your contract, which means that now anybody who uses this contract will actually end up paying you money for this. This is basically the foundation of how DeFi works. So DeFi or decentralized finance is a very hot term right now, but at the very root level, what that means is that it is an economy which is governed by a smart contract which executes every time a function is called. So for example, if I were Alice, I deployed this contract and I just disappeared from the internet, this contract will still perpetually exist, and anybody who uses this contract will actually be fueling it. Since I am the only one, I can come back 5 years or 10 years later and I can simply call the withdraw function to get my funds back. There is no arbitration in between. There is no government or no bank involved. I'm simply providing a service on the Ethereum blockchain and people are paying me for it. This is the power of DeFi, and this is essentially, fueled by this simple concept of adding something as, simple as a withdraw function or a payable statement inside your contract. So I hope this was meaningful, and you have a better understanding of how DeFi actually functions at a code level. So thank you for joining, and I'll see everyone in the next video.